Hi everyone, it's Mrs. Weir, and I'm here to introduce you to the Week 2 lab activity. We're going to be investigating density. So on your screen, this is the first part of the Week 2 lab in Connect. And let me show you how this activity works. There we go. Let me show you how this activity works. In the first part of the lab, you're going to be measuring an object of unknown density, and we're going to be suspending it in different solutions. The most important thing from the screen right here is to remember that the formula for density is going to be mass divided by volume. That's what determines the density of an object. You can also compare the density of an object by floating it in a solution. And depending on the density of the solution to the density of the object, that item will either float, it'll sink, or it can suspend. So if you have a liquid and a solid that are of the same density, then when you put the object in that liquid, it will float, or it will be suspended for the same density. If you have a liquid whose density is, there you go, you can see my hand. If you have a liquid whose density is higher, then if the object is got a greater density, then the object will sink. But if the density of the object is less than that of the liquid, then the object will float. So you can kind of tell and reference what the comparison is between the densities, and that's what you're going to be doing in this activity. So the instructions are down here at the bottom in the instruction panel, down here in the bottom in the instruction panel, and so you'll follow the instructions just as they're written. So here is your digital balance. Over here in front of the balance are some weigh boats. These are your small samples, and they're all small little plastic or polypropylene plastic black little squares, or cubes actually. Back here on the back are some graduated cylinders, and here are your three solutions: methanol, which is methyl alcohol, deionized water, and some ethylene glycol. So what the instructions tell you to do is tare and then measure, we just want to pick one, measure the mass of your little square. You can record that in the notebook. You know, what is the mass of one of the squares? So you're selecting the mass of one object and whatever the mass was, I don't remember, 0.018 grams. 18. Okay. Then you'll take your little dropper and you'll add some liquid to your graduated cylinder. Zoom in to see what the measurement is of your graduated cylinder, and it looks like I'm right about at 3 mils. So I'm going to go back here. I was doing methanol. It was 3 mils to begin with. Oh, not yet. 3 mils to begin with. I got to suspend it. So now I'm going to put my little object in here and measure again. Uh-oh. Here's a question I was not. I'm just going to pick this one and see if it tells me that I think that's right. I'm just guessing. Oh, I was wrong. Okay. So now it was 3 mils when I measured it before, and now it looks like it's about 3.1 mils. So the volume of this little tiny piece of plastic is actually going to be equal to the amount that the water was displaced. So because when you measure the density of something that's underwater, there's a law in physics that says two things can't occupy the same space at the same time. So what has to happen is when you put something under the water level rises equal to however much space that object takes up. So the difference between 3 and 3.1 mils is 0.1 mils. That's going to be the volume of my object by water displacement. So in my notebook area, I don't need the instructions. In my notebook area, it looks like under the liquid displacement, the volume of the liquid was by itself was 3. The volume of the liquid plus the object was 3.1, and I need to tell what liquid it is. I'm doing one object. And so the volume of the object is 0.1 mLs. They're going to have you repeat this for each of your liquids. And so again, you can follow the instructions step by step in this little method, and you're going to be determining the mass of the object, and then you're going to be on the second part in this screen, you're going to be doing a suspension method. This is kind of fun. You're going to try and create a liquid that will cause the object to actually float. And so I don't want to give it away. There we go. So there'll be coming a time where you'll pick some liquid, and I'm going to do this out of order just for funsies, so that you can see that sometimes the objects actually float. So on this one, if you look real carefully, the object didn't sink to the bottom, it's actually floating at the top. And then for another of the liquid, the observation that you might make is that the object, it doesn't float, it doesn't sink, instead it might be suspended in there. And so you might have to combine them a little bit later to see how much you can add in order to have it be suspended. So again, don't just goof around like I was doing. Follow the instructions that are in the lab, but I wanted you to see that depending on what you're putting inside the graduate cylinder, then your object may sink, it may float, or it may be suspended. See how it's not floating at the top, but it's actually not sunk at the bottom? This would be an example of a suspended piece of sample. Once you fill out all of your information in the lab notebook, it will let you advance to the next stage. So your assignment is to complete both stage 1 and stage 2 of the lab activity. There's 2 parts to it. And then the next thing that I want you to do is I want you to download the data sheet. I'm going to go back to Blackboard to our page. Here is the week 2 folder. And what I was working on just now was the actual lab, the density lab, but then you'll notice that there's this little link here for a data sheet. This is kind of the second part of the lab, and I want you to download the data sheet. I've uploaded it into 2 different versions, either a Microsoft Word version or as a PDF. You can type your answers in the Microsoft Word version, or you can print it and you can handwrite your answers and then upload a photo. But let me show you what the document looks like. What this document is, it's a sample of, there are some questions that you should be able to answer after completing the lab activity. So you'll type your name right in here. Whoops. So you'll type or handwrite your name right in here. And here we go. And on the first part, this is a little scenario talking about a student who did something very similar to the activity that we just did. The only thing is that you're going to have to calculate the density of the solution A, solution B, solution C. You'll have to calculate the density and then tell me, based on your calculation and based on this number right here, whether you would expect that little tiny cube to sink, float, or be suspended. I'd like you to show me your calculations. This might be cumbersome if you're typing, but I'd like for you to actually type out your calculations so that I know you know how to set up your calculations. I'm not going to type out the answer, but I know that you know how to actually do your calculations, or you can handwrite your calculations in this area. There's 2 pages to this document. This one's a little more complicated. You have a data table up here at the top that you're going to use for reference. And then down here at the bottom, you're going to have to fill in the empty boxes. Now these boxes that are gray, just leave them alone. There's no information that you have to calculate for any of these boxes. I should have put a non-applicable or something in here, but the gray boxes, you can just ignore them. Okay, ignore that box. I'll show you how this works. If you are looking to fill in this box, the volume of the sample, remember that there's two ways that you can calculate the volume of something. You can calculate the volume by measuring the dimensions, or you can calculate the volume by water displacement. And here's what I mean by using the dimensions. So right here I have a regularly shaped object. This is a rectangular box, and I can measure the volume of something that has a regular shape if I have something like a ruler, or in this case I've got a tape measure. Because everything that has a regular shape has three dimensions, you can measure the height, the width, and the depth. I can take those measurements of, how wide it is in this direction as compared to, this direction, as compared to if I turn it on its side and I measure it again. Those are those three dimensions, the width, the height, and the depth. If I take those three numbers and I multiply them, then I can get what is the volume of this regularly shaped object. Things that are kind of squarish or rectangular, that's an easy way to measure the dimensions, is height, width, and depth. If you have something that's cylindrical, kind of like shaped like a Coke can, then you can measure it using the volume of a cylinder, using your geometry. So for this data table where I have the dimensions listed here, I'm measuring the dimensions, the height, the width, and the depth of something that has a regular shape. Probably something that's very similar to the box that I was showing earlier. So if I was wanting to calculate the volume of something that I know its regular shape, all I have to do is multiply those three dimensions, and I'll get my answer actually in centimeters cubed, because it's going to be centimeters times centimeters times centimeters. Well, it turns out, as luck would have it, 1 centimeter cubed is equal to 1 milliliter. In fact, that's the definition of a milliliter, is 1 centimeter cubed, measuring something in three dimensions. So if I was measuring what is the volume of this particular sample, and once you know it, I don't have a calculator on me. What is that number? 2.5. You probably have it calculated faster than I do. 2.5 times 3.8 times 2.9. Then my exact answer is 27.55 centimeters cubed. Oops, I put it in the wrong place. 27.55 centimeters cubed. That's the same thing. That's the same thing as 27.55 mLs. So centimeters cubed or mLs, exactly the same thing. There's no conversion between them. Now, if I'm reporting this in the correct number of significant figures, if I look at the three values that were given as my measurements, the 2.5, the 8.1, and the 2.9, they all have two significant figures, so I need to round this to exactly 28. Oh, this is going to be cute. 28 point mLs. Let me, 28 mLs. Or actually just 28. Why am I putting a point? 28 mLs. So when you are given the dimensions like you are for regular shaped objects 1, 2, and 3, then this is how you're going to calculate the volume of the sample. When you have something that has an irregular shape, like samples 4, 5, and 6, that's when water displacement is really handy. Because then you don't have to try and figure out, was this shaped like a cylinder, or is it shaped like a cube? What is it shaped like? You simply subtract the values, and that's going to give you what the volume is by water displacement. And I would actually have to go, this is 15.0, just to three significant figures on this one. 1.14, that's three significant figures. There you go. That would be my answer for that one. Now, to calculate the density, remember that density is always going to be mass divided by volume. So the mass of this object